Hello everyone. I just wanted to give a small introduction as to what we will be building next on this YouTube channel, which is your own interpreter. This is again a challenge offered by code crafters, and you can use their platform. And in this challenge, we'll be building an interpreter for the language LOX, which is a toy scripting language, developed by this guy who works at Google. I forgot his name, but I have read his book called Crafting Interpreters. Oh, it's Robert Nystrom. I hope I'm not butchering his name. Anyways, it's a good read. I have gone through the first two parts of this book, and this book it's essentially the all the code you need to build your own interpreter for the LOX language. But Code Crafters has some differences, very minor differences, I suppose. I haven't gone through their challenge, but I'm pretty sure I'd be able to after having read that book. Anyways, they also recommend reading that book, and they essentially ask you to read the first three chapters of this book for the theoretical background for building your own interpreter, and like just so you understand what a context-free grammar is and how you can implement that context-free grammar. And by the end of it, we will have something that looks something like this. Now, I think this is the architecture for C or C++. I think so. Yeah. So they have the Clang and LLVM. Yeah, this is their compiler architecture. So in this challenge, we'll have something that looks like this, but only half of it. We have a Lexer. Lexer is just a scanner. It breaks the source code down into simple tokens that can be digested. Tokens are the alphabets of your programming language. Then we have a preprocessor. A preprocessor just marks a type to a token so that we can apply something kind of like a discriminated union on it. Not exactly, but kind of. So the Lexer breaks down the source code into tokens. The preprocessor determines what type of token a token is, and based on those types, the parser processes those tokens. So we will build a Lexer, and in that Lexer itself, we will do the pre-processing. And in the after the preprocessor, we'll have a parser. This parser builds an abstract syntax tree. Now, if you don't know what an abstract syntax tree is, I will go through it, but you should definitely read the book that Code Crafters tells you to read. I personally have read it. I've gone through the first two parts of the book, and that's enough to build an interpreter. The part three of the book is building your own bytecode virtual machine. Anyways, that's not in scope of this challenge. So after parser, we bypass all these LLVM steps. All right, the LLVM converts your programming language to assembly code, but we don't have that. We will be using Java and JVM to execute your abstract syntax tree. So your Java code will be able to execute different statements and expressions. And so we bypass this LLVM, and instead of IR generation, we directly have a Java-based implementation of an interpreter that will execute the abstract syntax tree created by this parser. Now we have something known as a semantic analyzer. Semantic analyzer is again a kind of a pre-processing step that sits between your abstract syntax tree creation and the execution. And here we can add stuff like resolution, like variable resolution, which scope a variable should be bound to. All that stuff can be implemented right here in this step, semantic analyzer. We can have multiple semantic analyzers. In this project, we will use one semantic analyzer called a resolver. That resolver will be able to determine which scope a particular variable is in. Let me give you an example. This is also example taken in uh, the book I was telling you about. So we have a variable global, and we have a function, we have a scope, and in that scope we have a function. Now this variable is part of the global scope, but when we create a function, it creates a closure over that variable. So anywhere, even after this scope, if I no, no like even after this scope, this function, the scope of this function ends. If we have a reference to this function, we will be able to call it and it should print global. All right, because we created a closure over it when we created the function. And as long as we have a reference to that function, we will be able to call it and it will print the global A. So if we call this function, it will print the global A. Now if we create another variable with the same name, but it's in a different scope, not the global scope. This variable is in an internal scope. That's why its value is block. All right. And if we call this function again, it should only be printing global and not block, because when this function was created, its closure included this global variable. So therefore, when we print it, when we call this function again, it will be referencing the global A, not the block A. Now this determination that this function is pointing to the global A and not the block A is done by the semantic analyzer. All right. We will be going more in depth as to what we will be implementing step by step, but that was kind of like the high overview of the project, of how it looks like. And I definitely recommend reading this book. His explanation is definitely better than mine. He works at Google and he created the Dart programming language. So it's definitely his explanations would be better than mine, definitely. So I recommend reading his book. And I have taken his code and I have done quite a bit of changes to it. I don't know if those changes are good, but I understand the code that way much better. Now, appealing to authority, I think maybe his code is better, but I understand my code better. That's why I have written it that way, and that's how I will be showing it in this project playlist, kind of on YouTube. So stick around for it, and I'll see you in the next one. Now, before we start implementing the interpreter, we should probably go through how the language looks like. So in the logs language, we print to the console using this statement, print statement. It's a reserved keyword in this language. The language is dynamically typed and it is garbage collected. All right. For data types, we have booleans, we have numbers. So numbers are integers and decimals both inclusive, and then we have strings, and we do have empty strings like this as well. And for null, we have nil. So in code, it looks like small nil. And in the language, we can use operators for expressions. We can add two expressions together. We can subtract, we can multiply, and these will be numbers here, or some expression that resolves to a number. All right, like a parenthesis on the left side and a parenthesis on the right side, and both those parentheses should resolve to a number. Now addition is a special case because we can use plus to concatenate strings as well, and same goes for multiplication, division, negate operator. We can have -1. We have less than, we have less than equal to, we have greater than, we have greater than equal to, we have double equal to check equality, we have not equal to check equality. I think the issue is this Obsidian editor, it's showing it like this, but it's written like this. So like an exclamation and then an equal to, but this editor, that this notes taking app that I'm using, just makes it look like this, but it's just not equal to. And this is again a double equal to, and this should resolve to false because it's not like JavaScript. In JavaScript, everything is casted to string. I think so, I'm not sure. And in that case, I think this would have been equal. I think so. And then we have not true, this negation, Boolean negation operator. Then we have a logical and a logical or. Just like so in any other language, we declare variables using the var keyword, and when we do not initialize a variable, its value is nil. We have strings, and we can print variables, and that will resolve to the variable's value, and it would print bagels. If condition, we have if statements in this language. we have loops. For loops, we have while loops, and we have a for loop like in any other language. We do not have a post increment operator or a pre-increment operator, so we write it like this. And we can create functions using the fun keyword. All right, and we do not have to give any type. There are no types. It's a dynamically typed language, and from functions we can return some value, and we can call those functions like this. Now, if you know JavaScript, or I think Java, yeah, in any Java also, in any language that supports functions as first class members, in that case, the functions, when you create a function, it creates a closure over it. So in Java, when you create a lambda, it creates a closure over it. All right, so you sh I hope you know what a closure is. If not, I will get into more details when we actually implement closures. Essentially, when you create a function, uh, it keeps a reference to all of its enclosing, to all the variables in its enclosing scope. So even if the scope, if we are out of that scope, but as long as we have a reference to the function itself, we can call it, and inside that function, we would still have access to the variables of that scope, even if we are not in that scope. All right, we can just call the function from any scope. That's essentially what is. We have nested functions, and this is an example of a closure. So this is an outer function, and inside this function we have a variable. We created a function and we returned the function. All right, so now when we call this function, and in this fn we get a reference to this inner function. All right, now we can call this function, and this variable outside will not go out of scope. It will print outside here. That's essentially what a closure is. You would typically expect this to be garbage collected, but it won't be as long as we have a reference to the function. In this language, we have classes. We, I'll get to it later when we actually get to implement classes, how they look like. We'll get to that later, but that's essentially what I wanted to show you right now. And this interpreter that we will be building will be using something known as a recursive descent parsing. All right, I will explain this in much more detail later when we actually implement the interpreter. You will see how we are implementing, how the abstract syntax tree is executed recursively. But in this video, I just wanted to give you a short introduction into how the language actually looks like. All right. So that's it for this one, and I'll see you in the next one.